If you are new and trying to get into DevOps, cloud, or SRE, can really get overwhelming. The mistake a lot of people make is to open one of those roadmaps. You know, those wall of roadmaps, and you look and you see a lot of tools like Linux, networking, you know, Git, Docker, Kubernetes, Terraform, Jenkins, AWS, Azure, Prometheus, Grafana. That's a whole lot of tools. And your brain will be like, where do I even start? And I get it. DevOps can be like a whole large wall of tools. But the underrated advice I can give you right now is to learn problems and not tools. You see, those tools were created as a result of problems. People have issues and we're looking for solutions. And that's how those tools came about. For example, Docker was created because of inconsistencies in deploying applications. Kubernetes was created when we tried to run a lot and lots of containers and manage them. Terraform was created because of inconsistency and the risk that involves when trying to create infrastructure manually. CI/CD was created because trying to deploy and test infrastructure manually was a pain. And then monitoring happened because systems fail, right? And we want to see our systems fail before our customers do. So you see, so instead of learning tools, I'm becoming a tool collector, learn problems. And that's how you become an engineer. And the difference there is massive. My name is Dibal. I am an SRE engineer and I work on live production systems. In this video, I try to explain to you the tools to learn for DevOps, SRE, and cloud engineering in the right order, in a practical order, in a problem-first order. So by the end of this video, you should be able to understand not only the tools to learn, but why these tools even exist in the first place and how these tools work together. Number one, let's start at the foundation, Linux. Before learning Docker, before learning Kubernetes, before learning cloud or Terraform, you should learn Linux. Absolutely, because Linux is the foundation which every other tool in the DevOps space is built on. Servers are built on Linux. Containers are built on Linux. Kubernetes nodes are built on Linux. Even CI/CD pipelines, runners are built with Linux. So you should absolutely learn Linux. And again, if things break, you end up in the terminal trying to check systems, trying to check logs, trying to navigate in the terminal. And that's all about Linux, knowing some Linux commands so you can navigate through the environment. So if you understand the environment in which every other thing is built on, it gives you an advantage. But if you don't, every other thing, you have a bad foundation. So every other thing in the space will look like magic. So absolutely start from Linux. Next is networking. Yes, I know it's not the most exciting topic, right? But in SRE and cloud engineering, networking is everywhere. A database not connecting to a service, or a DNS not resolving properly, or a load balancer sending traffic to the wrong targets, or a security group blocking a port. These are just common issues, everyday issues in DevOps and cloud engineering. So you need to understand the basics, such as subnetting, routing, IP addresses, CIDR ranges, security groups. You need to understand HTTP, HTTPS, TLS, etc. The goal is not to make you a network engineer, but in modern day cloud systems, these are just computers that are talking to a different set of computers in a network. So you need to understand when this communication breaks, you need to understand why. So if Linux teaches you the environment in which applications run, networking tells you how these applications communicate to each other. The next thing to understand is Git. Yes, Git is not only used by developers. In DevOps, almost everything becomes code. your pipeline becomes code, your infrastructure, your Terraform modules, they become code, your manifest become code, your Helm charts become code, your configurations become code. So because everything is now code, it needs a way to be version controlled. That is where Git comes in. So Git solves the problem of tracking changes, such as who made what change, why was it made, when was it made, how do multiple people collaborate to a project without overwriting on each other. That's Git. Git solves that problem. So you need to learn about Git commits, you need to learn about Git branching, Git rebasing, conflict resolution, and merging requests. Because in real projects, in real teams, you don't just make changes, but you make changes that others can review, they can trust, and can be tracked. After learning Git, I'll say you choose one scripting language. And if I had to choose one language, I'll choose Python for longevity. Bash is good. So it's good to understand some batch command, but Python gives you more room to grow because in DevOps, there are a lot of repeated activities such as passing logs, calling SDKs, writing reports. That's just part of DevOps. And DevOps is not just about clicking buttons, but it's about looking at what you do, looking at your repeated activities and asking, how can we automate this out? And that's where a scripting language comes in, and Python will give you that leverage. At this point, hopefully you've understood Linux, networking, Git, and you've picked up one scripting language. The next thing to do is to build something. Yes, this is one of the most crucial steps that people skip. They want to be DevOps engineers, but they've never built even something small. And that makes learning DevOps really hard and difficult because I believe that DevOps sits in between development and operations. So you need a little of dev and a little of ops to be DevOps. So build something, no matter how small it is, even if it is a small Python Flask app or a Node app, or even if a basic API, just build something. The goal is not to be a full-time developer, but the goal is to understand what you're deploying. If you don't understand how the app you're deploying is built, if you don't understand how it starts, if you don't understand how it uses environmental variables or how it connects to database or how it logs, it becomes very abstract learning how to deploy that app. So build an app, run it, start it, break it, and fix it. That is where real learning starts. If you want ideas of projects to build, I'll link them below this video. Next on the list is Docker. Docker solves a specific problem. The app works on my machine, but it doesn't run on yours problem. So at this point, you've already built your simple app we talked about before. Now you understand that your app can run locally on your machine, but when somebody else is trying to run that same application in their own machine, they will find difficulties. And that's exactly the problem Docker solves. So Docker containerizes the application, its environment, the version, and its dependencies into a container and deploys that container. So in every machine, that container can be deployed. Its environments are involved, the versions and the dependencies. So it runs on every environment. So that's the problem Docker solves. So because Docker made it easy to deploy applications on different environments and spin them up, people were able to start and deploy applications easily. So they went from one application to 100 applications to 1,000 applications. They scale it up, and that created a new problem. And that's where Kubernetes was born. How do you manage these applications at scale. If the applications go down, assuming 1,000 applications, how do you spin them all up immediately and get your services back? That's where our next tool comes in, Kubernetes. To learn the pain that Docker solves, pick up that your simple app that we built earlier, run it locally, and then containerize it. Write a Docker file, build an image, run a container, expose ports, pass environmental variables, use Docker Compose and database, and then you feel exactly how important Docker is. Next is Kubernetes. Kubernetes is hard to appreciate if you've never felt the problems it solves. If you've only run one container before, then you feel Kubernetes is an overkill. But imagine running hundreds of servers across many containers, needing scaling, needing self-healing, needing service discovery, and rollout control. Then you begin to understand why Kubernetes makes sense. So Kubernetes is actually for running containers at scale. Let's talk about CI/CD pipeline. At the core of DevOps is pipeline release. Every code changes should go through a test, and then images being run, packages being built, and then security scanned before deployment. This whole flow should not depend on someone manually clicking buttons. So CI/CD pipeline solves the problem of slow, risky, manual, intermittent releases of code changes. The concept here matters more than the tools. The concept is that every code changes should run through a predictable path of building, testing, packaging, deploying, and then verifying. So don't fall to this tool war. Just pick one tool. It could be GitHub Actions, Jenkins, Concourse, Azure DevOps, whatever tool you want. Just pick one and learn. I think Azure DevOps is very accessible, and GitHub Actions too is very accessible to if you're new. And a lot of companies are also still using Jenkins. So it doesn't matter the tool. What really matters is the concept of building, testing, packaging, releasing, and then verifying too. So whatever tool you learn just goes through that concept. To make this real, pick up your simple app that we built before, push it to GitHub, create a pipeline, run tests, create Docker images, push it to Docker registry, and deploy it somewhere. Then everything looks real. But the question is, where do you deploy this to? Now that brings us to cloud, such as AWS, Azure, etc. Like I asked, where do you deploy your small app? You can choose to deploy it in the cloud, because if you choose to run your own servers, it's expensive and it's painful to manage and a lot of work. So most companies choose to rent infrastructure from the cloud, because the cloud acts as ready to use infrastructure for you. Companies just rent infrastructure from the cloud. It could be AWS, Azure, or Google GCP. Whatever is your choice, just choose. But the goal is to learn how to deploy these infrastructures in the cloud. So instead of learning all of them, just pick one, maybe AWS. I would recommend AWS. And you can learn compute, networking, storage, and databases, whatever you want to deploy. But this leads to another problem, because you are deploying manually from the console. It's difficult to trace. It's difficult to redeploy in case your infrastructure goes down during a disaster. How do you recover? That leads to Terraform. Terraform helps us to deploy repeatable infrastructure. We can deploy the same infrastructure in different environments. We can have identical pre-production, development, and production environments, because We're using Terraform, which acts as an infrastructure as code. So if you have a disaster, we can easily recover because we have our infrastructure stored as code. So learn Terraform after you understand basic cloud, because Terraform makes sense when you know the resources you are deploying. So learn providers, resources, variables, output, states, modules, remote backend, plans, applies, and most importantly, learn why state matters. Because Terraform is not just about writing code, it's about managing the desired state of infrastructure. Now I know you might be thinking, but that's a lot of tools, and I agree. Linux, networking, Kubernetes, Git, Cloud, Terraform, Python, that's a lot of tools. But here's a mistake a lot of people make. They try to learn everything at once. They jump from one tutorial to the other. They try to collect certifications, memorizing commands, and learning tools in isolation. And 6 months later, they still can't remember or build anything. That's because DevOps isn't really about tools, it's about system. It's about understanding how a software can move from just an idea and to running reliably in production. Next is configuration management. Tools like Ansible. Now, Terraform is great for provisioning infrastructure, such as server, network, or cluster. But sometimes we need to configure what's going to run inside the machine. For example, we want to install packages, or we want to patch services, configure services, or we want to apply security changes, or run commands across many hosts. That's where Ansible fits perfectly. So Ansible solves the problem of configuring many machines consistently. But I wouldn't put Ansible before Linux, because Ansible automates what you should understand manually. If you don't understand a package, or what a service or permission or config is, Ansible just becomes another layer of confusion. So what I would say, first, learn Linux and then use Ansible to automate it. Now we get to monitoring and logging. This is where DevOps starts becoming SRE, because deploying an app is not enough. You need to know if it is healthy. You need to know if it's failing, and you need to know when it is slow. You need alerts to alert you first before your customers start complaining. So Prometheus alerts for metrics, Grafana visualizes them, and then logs help you understand what happened. Alerting tells you when something needs attention. As I said before, don't learn monitoring as a tool. Instead, ask the following questions. Is the service up? Is latency increasing? Are errors increasing? Is the CPU or memory saturated? Is the database under pressure? Are users affected? So that's the point. And if you're serious about SRE, go further. Learn about SLIs, about SLOs, error budgets, incident response, and postmortems. Reliability is a way of thinking, and that's the part a lot of roadmaps don't explain properly. The tools are not separate, they work together. This is the real skill. You write a code, you store it in Git, a CI/CD pipeline runs, it builds a Docker image, pushes it to Docker registry, and deploys it to Kubernetes. Kubernetes runs in the cloud infrastructure. Terraform is used to create that infrastructure. Prometheus help us monitor it. Grafana visualizes it. And we debug it with the help of logs. Then Python helps us automate all the boring tasks around it. Then Linux sits underneath almost everything. That's DevOps, not tools in isolation. It's a system. And this is why learning tools in isolation can become overwhelming, because it's like we're collecting tools of a machine we really don't understand. Instead of asking, what tool should I learn next? Ask a better question. How does an application works? How is an application deployed? How does an application break? And how do we monitor applications? How do we recover applications if they break? Because every tool that we discussed today fits inside this story. And again, that's why I think a lot of people struggle to learn Kubernetes. They try to design a city before they even understand how a single house works. More people want to learn Kubernetes before they've ever deployed an application. And I think that's the wrong order. Let's make this really practical. For every topic, do one project, not 10 projects, not 100 tutorials, just one project. So if you learned Linux, build something. If you learned Docker, containerize something. If you learn CI/CD pipeline, then automate something. And after every project, push it to GitHub, write a README, talking about what you built, what problems it solved, what broke, and what you learned from the project. Because that README isn't just a documentation, it is a proof that you actually understood what you built. Let's talk about AI, because ignoring AI will be a mistake. You can absolutely use AI to learn DevOps today. Use Claude, ChatGPT, or some coding agents to explain concepts, generate practical labs, help with Bash or Python scripts, or troubleshoot Docker errors. Can also help you in reviewing your Terraform codes, explain Kubernetes events, but here is the rule. Let AI accelerate you. Don't let AI replace you. If AI writes a script, make sure you read it, you understand it, you can explain it, because if you can't explain it, you don't own it. AI is very, very useful for tedious jobs. It's very useful when you are stuck, and it can help you learn faster. But your job is still to understand the system. One more trick that's very useful. You can reverse engineer the career that you actually want. Go to job sites like Indeed or LinkedIn and search for the roles you want: SRE, DevOps, platform engineering, or cloud. Now, look at the job descriptions. Look at the tools that appear frequently. Then build your roadmap around real demand, so you don't waste time trying to do several tutorials or picking up certifications. Your goal is not to look busy. Your goal is to be useful. I have to summarize the whole video. I will say this: don't learn DevOps as a list of tools, but learn DevOps as a chain of problems. How do I run an application? How do I package an application? And how do I test it? How do I deploy it? How do I create infrastructure for an application? How do I scale it? How do I monitor it? How do I recover an application if it breaks? So every tool answers one of these questions. And secondly, try to be in a community, because it helps. In a community, you can have people to share resources with, people to answer questions that you might have, or people to be accountable with. Because like they say, if you want to go fast in a journey, walk alone. But if you want to go far, work with others. If you care about joining a community, I have one of those communities you can join for free. Comment the word community below, and I'm going to add you to that community. If you like videos like this, please don't forget to subscribe. And thank you for watching this video. Bye.